Before we get into specifics, I want to talk about how we perceive mathematics and how concepts develop. Often we think math as a set of problem-solving skills and facts. This isn't wrong, but this view severely limits another important aspect, that as our understanding of the world progresses, so does mathematical concepts. Take numbers as an example. We start with counting numbers and teach how to do basic arithmetic, like using distribution to multiply numbers. Later, we talk about fractions and decimals and eventually land on algebraic manipulations. But as far as arithmetic goes, the principle behind it is the same. It's just that we use the same law in a broader scope, often taking the underlying step, as in this case 23 times 7, as granted. So what does that have to do with having different perspective? In order to properly develop mathematical concept, it is important that we create proper challenges and encouragement. And giving these allows students to manipulate the concept on their own. This approach is very well reflected in the design of the standard we actually use today. Let that be Indiana Academic Standards or Common Core State Standards. I recommend you take a look into those standards on your own. So with that in mind, let's look at the word angle. If you haven't done already, work from problem 6 to problem 9 in the packet on your own and come back to the video. So what is an angle? It is used in different ways, but at least in math, it can be summarized in the following way. 1, it is a shape formed when two lines meet at a vertex. Or 2, it is the measurement of the space between lines, often measured in degrees, and you would draw a picture like this to indicate that this is the angle that we're interested in measuring. Or another way of seeing it is think of it as the amount of rotation from one ray to another. So you draw a line like this and think about rotating, and you're really measuring how much you have to rotate. And finally, we can also think of it as a coordinate or a direction on a circle. So if you have a circle, we can think of it as what time it is and thinking of it as some kind of a direction. That can be also thought as an angle. Let me point out, except for the first one, in terms of the measurement, there's no superiority in the definition we use. It simply serves different purpose from time to time. Let us explore more deeply. Let us think the angle as the measurement of space or wedge. In this view, less of an angle, less of a gap they have in between. If you have two different angles, we could always compare which one is larger simply by shifting one to another, which is exactly what we talked in the previous video. And in this physical viewpoint, we can see some of the properties of the angle. That is, if you shift an angle to different position, there should be no change in the angle. Also, if you have an angle and if you rotate it, there should be no change in after the rotation. And finally, somewhat less apparent, if you increase them in size and just simply extend the lines, there should be no change in angle. So these are some of the properties that we actually use in the measurement of the angle. So if you want to draw an angle that measures 58 degrees, we can imagine a 60-degree angle and make the angle slightly acute. And by the same logic, if you want 121-degree angle, we can imagine a 120-degree angle and slightly make it wider. That way we can get a sense of what 58 degree is, because they are supposed to be very similar in angle. So let's talk about the rotational view of the angle measurement. So one question we can think about is how to measure or how to draw an angle whose measure is 277 degrees. If you remember from the previous video, 277 degree angle is a reflex angle, an angle whose measure is greater than 180 but still less than 360 degrees. So if you actually draw that, it'll be a picture like this. But it's not clear from the picture which side we're talking about, because if you actually think of this as the measurement, you can think about this acute angle that you see right here, or you could think about the other side of the angle, which is right there. Now, by drawing a circle, we're already emphasizing that we're thinking the one ray on your right is rotating clockwise to the ray on the top. And we can ask a similar question such as, how do you describe an angle whose measure is 540 degrees? Which you would start looking at a ray and then think of it rotating a full circle and a half, which measures 360 plus 180 degree rotation. So let's say we're given an angle and we would like to measure it using a protractor. As you probably know, we will first have to center the vertex and then align one of the edges to 0 degree. Sometimes we have to extend the segment so that you can read the marking on the protractor. This is you're already using the fact that the scaling doesn't change the angle, which is some of the property that I talked about. Now, you don't necessarily have to line the first ray to 0, because if I start with, say, 40 degree, the rotational viewpoint allows to see this as a rotating from 40 degree to 80 degree. Which also tells me that this is 40 degree in measurement. And finally, we may even think of this point right here on a protractor as some kind of coordinate, in which case the coordinate marking tells me that 40 to 80 is somewhat like a distance. And 40 degree measurement is really a distance between one ray to another. So we can already see, even in this example, there's an interplay between different concepts. One that talks about angle as a measurement of a gap, and then another viewpoint that thinks of it as a rotation from one another. And finally, the last one is thinking that as a coordinate on a circle. So here's a summary. So an angle as a word, just simply a shape, is a figure formed by two rays and a common vertex. Or if you're talking about the measurement, then it's the measurement of the shape angle. Depending on what angles you want to measure, we can view this as a measurement of the space between two rays, or measurement of the rotation from one another, or a coordinate on a circle that you draw. Of course, there are some preferred ways of thinking about this. 18 degree would be easier to think about as a gap between two rays, which is similar to, say, 20 degree angle. Whereas if you're thinking about 183 degree, it'll be easier to think about a straight angle and then rotating it a little further, and so on. But that doesn't mean that other concepts are not being used when we're thinking about angles. So next time we're going to explore how these notions and concepts interplay in more depth. Thank you for watching, and I'll see you next time.